All right, so let's look at this problem. We want to know how much energy is needed. By the way, don't forget energy is Q. So eventually we're solving for Q. How much energy is needed to warm 100 grams of ice? So first of all, you've got 100 grams of ice. So that is our mass. Now that mass will stay constant the whole time. So whenever we get equations with M, we know we can plug in 100. That will be nice. Now, we want to warm the ice that's at negative 10 degrees Celsius and turn it into 100 grams of ice at 0 degrees Celsius. Okay, so let's think about it. There's not going to be a phase change here, as it says. So we're just staying with solid ice. So we're going to use step A because we're going to start warming up the ice. In fact, the ice is going to start at negative 10 degrees Celsius and end at 0 degrees Celsius. So the ice is going to heat up, but it's not going to start melting yet. So because of that, since there's no melting, we won't have to use the phase change part. So what does that mean? It means we're only in part A and we're only going to use this equation. All right, so we can do that. Let's write out our equation first. Q equals mc delta T. All right, I'm solving for Q, so I'm going to leave my Q there. Do I know my mass of water? Absolutely. It's 100 grams. Do I know the specific heat of ice? Yes. It's not given to me, but I can look that up on any of my old specific heat worksheets, whatever, or I can look that up online. But the specific heat of ice I know is 2.03. That's the C value for solid ice. It's different than the specific heat of water. That's 4.184, I believe. So make sure you're using the proper specific heat for the proper phase of water. Since it's solid ice, you have to use 2.03. Now, the last step is the change in temperature. Remember, side note, change in temperature is final minus initial temperature. So, what is the final temperature of this ice? It's 0 degrees because that's what it's going to end up at. Minus the initial temperature. The initial temperature is negative 10 degrees. So when you minus a negative 10, isn't that really the same as addition? So when you do 0 minus 10, you really end up with a positive 10 value. All right? So now we can do the math across. It's going to be 100 times 2.03 times 10. So when you do that, put the 2 down. When you multiply by 100 and times 10, you're really moving the decimal place over 3 places. So 1, 2, 3. Your answer should end up being 2,030 joules. Now, the math is not the difficult part. What I've noticed in years past is students get overwhelmed by the question. There's ice, there's words like water, there's temperature, there's a chart. So literacy here is the hardest part. You've got to take your time, you've got to draw on your map or diagram, and you've got to figure out, okay, where am I starting on this chart? What is that temperature? Now, am I going to go from one part of the chart to another? If I am, when I get to that part, let me write down what the temperature will be before I go from A to B. Do I go to another part? If I do, what will be that temperature? Remember, when ice is done melting, it's still 0 degrees Celsius, and then the temperature heats up. If I'm eventually going to boil, I know that water is going to start boiling at 100 degrees. If you don't know these straightforward things that you're expected to know, all right, then it does become very confusing and difficult. So you've got to work on your literacy. You have to know that ice melts at 0 degrees Celsius. And when ice melts, you're going between liquid and solid. You have to know that water boils at 100 degrees, and when it does, it's going from a liquid to a gas. You've got to know that at 50 degrees Celsius, water is in the form of a liquid because it's between 0 and 100 degrees. You got to know if it's negative 20 degrees, you got to know that water is frozen solid and it's a solid phase. Okay? So literacy is going to be a huge part here. You want to run through that. So don't think that this math problem is insanely difficult. It's not. You just got to understand about your water and you got to sift through all the information. All right, if we look at this next problem, it says how much energy is needed to melt 100 grams of ice So right away, 100 grams of ice, which is 100 milliliters of ice, is 100 grams is M. How much energy do I need? Energy is really my Q value. I need to solve for Q. And I'm going to melt that ice at 0 degrees Celsius. Of course, that's at 0. Ice always melts at 0 degrees Celsius. So it looks like right now, at least part of this problem, I'm in the melting the ice phase, part B. Oh, and I want to go from 0 degrees Celsius ice to 100 grams of water at 0 degrees Celsius. So notice, from 0 to 0 degrees Celsius, I'm only going to use step B. I don't need to worry about A or C or D because I'm working in the parameters of 0 degrees Celsius. Since there's no change in temperature either, it's no crazy thought that temperature isn't involved in this problem. In fact, the equation we're going to use for this problem is our Q, our heat or energy, is going to be equal to the heat of fusion. And the heat of fusion, remember, is the unit or value that we use whenever we're melting something times its mass. Okay, well, we can plug in for that. My Q value is going to be equal to the heat of fusion for water. The heat of fusion for water, as noted back in our earlier slides, is 334 joules per gram. And if you multiply that by the mass of the water, which is 100 grams, this becomes very straightforward. Becomes 33400 joules. So the total amount of energy to melt this 100-gram block of ice is 33,400 joules of energy. Now, if you would have taken that and added that with the previous one, if that was all one problem, you could have added both those energies up, and it could have told you how much energy it took to go from negative 10 degrees Celsius and then actually melt that sucker to 0 degrees. You could have added up both those energies, and that would give you the total energy. All right, so let's do a two-step kind of problem here, and this one's great practice for that. Let me get a couple pieces of information, first of all, down. All right, I did a couple of values that I think we're going to need and use later. And remember, these values aren't always given in the problems, but you can look them up. You are not helpless. You can look them up on the internet. You can look them up on previous slides from notes, and you can look them up on previous worksheets too. So you have to be resourceful in life. Not all the information is ever given to you. You got to go out and find it. All right, so how much energy is needed to change 25 grams? Okay, so first of all, I've got a mass of 25 grams of a substance here, and I'm looking for energy. So in the end, I'm looking for my Q value. All right, it sounds like I've got ice at negative 10 degrees Celsius, and I'm going to convert that to 25 grams of steam at 100 degrees Celsius. Wow. Okay. There is going to be a phase change here, quite a few. So I'm starting at ice at negative 10 degrees. So I'm at negative 10 degrees Celsius. Okay. And if I'm going to eventually turn to steam at 100 degrees, that means I'm going to end all the way over here. So I'm going to have to first heat up my ice to 0 degrees Celsius so that it can start melting. When it's done melting, it'll be at 0 degrees Celsius and it'll be liquid water. I'll then heat up that liquid water, and once I get it to 100 degrees Celsius, I will then boil it. Remember, when it's ice, it's solid. When it's melting, it's going from solid to liquid. When it's a liquid and heating up, it's just a liquid. And when it starts boiling, it starts converting from liquid to gas. But notice I put in my temperatures. Those temperatures will be important, and you need to know those. But this becomes a few steps. First, you're going to need to figure out the energy it takes to warm up the ice to get it to melt. Then you're going to need to heat up the ice so that eventually it can completely melt and turn to liquid. Once a liquid, you're going to need to heat it up so you can get it to its boiling point. And once it's at its boiling point, we need to figure out how much it takes to actually boil it off. All right, wow. A lot of information. I'm going to scoot up my slide here so that I can get some more room for work. All right, so let's do this one at a time. So I'll just do 1, 2, 3, 4 little different problems, And when I do that, once I get all my Q values, I can add all those up to get the total amount of energy. So step one is Q equals MC delta T. All right? Now, I need to solve for my Q value, easy peasy. My mass for this ice is 25 grams. And my C value is the specific heat of ice. So when I look on my chart, the specific heat of ice, the solid phase is 2.03. And I'm looking at my change in temperature. All right? My change in temperature is final minus initial. So the final temperature in this box is 0 degrees. I know a lot of people think, wait, isn't the final temperature 100? That's true at the very end, but in this box, the highest temperature you can go is 0 degrees. So it's going to be the final temperature minus initial, so 0 minus a negative 10 degrees. Okay? If I rock that out, don't forget 0 minus a negative 10 is actually a positive 10. Let me put that in my calculator, and we can figure out what we get for our Q value. 507.5 joules is what I get. Okay, so that's part one for my energy Q value, but I'm not just there. I need to go to part two, which is melting the ice. So if I'm going to melt ice at 0 degrees Celsius, there's no change in temperature. So that means I'm going to use the equation that has to do with melting, which is the heat of fusion. Now my value for heat of fusion is specifically for water. So if you remember from our previous slide, the heat of fusion is 334 for water, and we're going to multiply that by the mass of the water or ice, which is 25. If I throw that in my calculator, I end up getting 8,350 joules. All right? That number, again, is going to add towards our total energy, but we're not quite there yet. We still have to do part three. Fine, we can rock that. Let me get a different color, green for that one. Now I'm in the liquid phase for part three. That's important to keep in mind because with my equation that I use for section 3, my C value has to be the one for the specific heat of liquid water. So let's do that. The mass we know is still 25. That's the same throughout. The specific heat of water, if you remember from our previous problems, and you can always look up on our old worksheets or on Google or something, the specific heat of water is 4.184. Now the change in temperature is final minus initial, but be careful. You have to know where in part C the temperature begins and ends. That's why we took notes on that. Remember, when melting phase is just about done, you're at 0 degrees Celsius, and just before you boil, or when you start to boil, you're at 100 degrees. So that means in part C, the final temperature at the most will be 100 degrees, and the initial would be 0. So 100 minus 0 is just 100. So if we throw this in our calculator, it would be 25 times 4.184 times 100. That gives us, if you throw in your calculator, 10,460 joules. Now again, this is a Q value, an energy value. That's going to be added to the total energy as well. So the last step here is part 4. And don't get overwhelmed. Remember, these are a lot of steps, but they're very straightforward math. You're literally just multiplying together 2 or 3 numbers, as long as you're putting the right numbers in. Does that take time to think through? Absolutely. You got to take your time. You got to work through it, okay? But that's going to help you in the long run with your literacy, understanding how all these different moving pieces work and plugging them in. So let's do our last step here, and I'll stay with red for part 4. Because there's no change in temperature, you're just going from 100 degrees to 100 degrees, the equation has nothing with temperature in it. But since you are boiling, that's specific to the value called the heat of vaporization. So if we're going to plug in for that, the heat of vaporization does have a specific value for water. That value is 2,260 for the heat of vaporization, and the mass of water has been the same throughout. It's been 25. So when you put that into your calculator, 2,260 times 25, you end up with 56,500 joules. Now that's another energy amount. So I've blocked off all the 4 energies, part 1, part 2, part 3, and part 4. So if we're looking for the total energy of the system, that means I would need to add up 507.5 plus 8,350 plus 10,460 plus 56,500. And if I added those all up, I would get a total of 75,817.5 joules. Let me write that in a nicer color for you too. 75,817.5 joules is the total energy it took to actually melt this solid negative 10 degree block of ice into boiling it into the gas phase at 100 degrees. All right? So when you step back and look at this, this looks like an incredibly large amount of work. And it is. There's 4 steps, quite a bit. But when you really stop and think about it, the fact that you're just using 2 different equations, equal Q equals MC delta T, or you're using the Q equals whatever the phase change is times mass. You multiply them, which is no problem for you guys, and then you just add up all the numbers. Easy peasy, mac and cheesy. So remember, something that's time consuming isn't necessarily difficult. So don't turn your brain off saying, oh, this is impossible, there's so many steps. Nope, just take one step at a time. Is it time consuming though? Absolutely. But there's a difference between something being difficult and something being time consuming. I've been working on yeast doughs and yeast breads, which I used to be intimidated by. I thought they were difficult to make fresh bread with yeast. But actually, it's just time consuming because you have to take time for the yeast to rise the dough and proof it. But now that I've been doing it, I can't believe I've waited so long to get good at it. It's no big deal. I just have to have the time in order to raise the bread. So remember, time consuming does not mean difficult always, all right? So take one step at a time. You'll be just fine. Great job, science fam. Keep up the good work. And we'll start doing some practice problems with these. Be well.